Welcome to CEC lectures. We are presently going through the lecture series of advanced data structures and algorithms, and our previous topic which we covered in our previous lecture was the basic operations on lists. So, without wasting any further time, I am just going to continue from where we have left in our previous lecture. Please recall that in our previous lecture we were kind of covering or we were trying to understand about the function which is there to delete the elements, and there were two versions of that function. The function is basically the erase, and the version which we have seen is the deletion of or the removal of only one particular element. And now here we are going to use that erase function in order to remove or in order to delete a particular range of the elements. So, in order to look into it in a complete manner, let us begin with this program. So, we have our main function in which we have created a demo list, and we have pushed back 5 elements which are 10, 20, 30, 40 and 50, and this we have seen in our previous lecture also. So, now your list is having 5 elements which are 5 elements in a specific sequence, which is 10, 20, 30, 40, 50, and in order to print the elements before deleting any element from that, we are going to use our iterator which will start from demo list dot begin and it will go till demo list dot end, and it will keep on incrementing itr plus plus, and the value which is being printed with the help of cout function is going to be asterisk itr, which is the value at that particular position of itr. Now, here we are going to kind of play around with the help of advanced function. We will be playing around with the kind of iter2 iterators, and then we will delete some elements. So, in order to have a complete look, let us see. So, here we have taken 2 iterators, one is itr1, another one is itr2, and both of these are type of kind of integer list. So, itr1 is demo list dot begin. So, that means we have kind of set the position of itr1 at the beginning of the demo list. Similarly, for the second one, which is itr2, we have set the position at the beginning. So, now the 2 iterators are pointing towards the beginning position, and then we have incremented this itr2 by 3 positions by using the function advance, and this function advance we have seen earlier also. So, advance itr2 comma 3, that is incrementing itr2 by 3 position, and now with the help of erase we are going to give starting range and ending range as the parameters to this erase function, and we will be deleting the range of elements from index 0 till 3. So, 0 is given in a closed interval while 3 is open. So, the elements which we are going to delete here are 0 element at 0 position, element at 1 position and element at position number 2, not the element at the 3rd position, and this is what I have told you in the earlier lecture also, that whatever is the last element or whatever is the last position, the elements presiding or elements prior to that particular position will be kind of deleted. So, here we have demo list dot erase itr1 comma itr2. So, starting from itr1, which is nothing but the beginning, till itr2, which is nothing and pointing towards the 3rd position, whatever elements will fall in between, all those elements will be erased. And after erasing these elements or after execution of this erase command, we are going to print the list of whatever elements are remaining. In order to print that list, we are again using starting from begin to end. We need to kind of print asterisk itr, which is the value at that particular position, and then finally a return 0 in order to balance this integer main. So, if we see into the output, the list before deleting any element was 10, 20, 30, 40 and 50, and when we delete the element starting from the position 0 till position 2, not the position 3. So, element at 0 10, element at 1 20 and element at 2 30. All these elements will be erased, and the list after deleting the first 3 elements, that is from indexing 0 1 2, the list which is remaining is nothing but 40 and 50. So, in this way we can use our kind of erase. One more function which is kind of having the kind of similar functionality as that of erase is the remove function. That is also a built-in function in C++ STL, which is used to remove the elements from a list container. Now, in our erase, we were erasing the elements on the basis of position, whether the kind of a single element we are erasing or we are erasing a range of elements. Elements are being erased on the basis of their position. Here the function remove will take a value as the parameter and remove all the elements from the list container whose value is equals to the value passed in the parameter of the function. So, for example, in the parameter I have passed 10. So, whatever elements with the value 10 or whatever elements having the value 10 are present in the your kind of list, all those will be kind of removed, and the syntax is going to be list underscore name dot remove and value, and here there is no question which is arising and pointing towards the position. Position is not not relevant here, that is not being included. This remove is going to kind of delete the elements on the basis of this value, and this is what the basic difference between the erase and the remove is. Although they both are there for kind of deletion of elements, one is deleting on the basis of range, another one is deleting on the basis of value. So, for example, if you want to remove all the elements with the value 10, they may be scattered in a particular list. So, we can use the function remove. So, as far as parameter is concerned, this function is going to accept a single parameter which is val or value, which refers to the value of the element needed to be removed from the list. When we talk about the remove function, it will remove all the elements from the list whose value is equals to that parameter which is val, and it does not return any value. So, again, in order to understand this remove, let us see this with the help of a program. Some snippet of the code is matching with the previous one, in which we are creating a demo list, and within this demo list we are pushing back 5 elements which are 10, 20, then again a 20, 30, 40, and we have deliberately given here the double occurrence of 20, so that we can remove these kind of both the occurrence of the element 20, and we need to print the list before removing the elements. So, with a proper message we are starting ITR auto ITR is equals to demo list dot begin semicolon, that means we can read it out here. So, for ITR is equals to demo list dot begin to ITR not equals to demo list dot end, you need to kind of we can say you need to increment this ITR, and you need to print this asterisk ITR. So, the list before removing the elements will be kind of printed using this particular loop, and that is 10, 20, 20, 30, 40. Now, we will use the function remove to remove some elements, and here we the agenda is to delete all the elements with the value 20, and the syntax of the remove element remove is very simple, which says demo list dot remove, the value being passed here is 20, and then again after kind of removal of the we can say this element 20, we need to print the list. So, again we are using the same strategy for auto. ITR is equals to demo list dot begin, ITR not equals to demo list dot end, ITR plus plus, and we need to print asterisk ITR. So, if you can see into the output of this, so output will be something as it is given on the screen. So, list before removing the elements was 10, 20, 20, 30, 40, two occurrences of 20, and list after removing elements, both the occurrences of the element 20 are being erased, and what is left is 10, 30 and 40. Time complexity is order n, and auxiliary space which is required is also order n, because from here you can kind of you can remove multiple elements, and the the order or the big O of those number of elements is nothing but n, because n is the total number of elements in this. So, list before removing the elements was having 20. After removing the elements, the list is not having 20, time complexity order n, and auxiliary space requirement is also order n. So, we have seen kind of removing the elements. We have also seen the two versions of erase one, which is erasing a single element, another one which is erasing a range of elements. Moving further, we are going to use or we are going to study the clear function. Clear, as the name indicates, we use the term clear in our computer science domain when you need to kind of clear out everything. So, basically when we talk about list, these are the containers. They store data in a non-continuous fashion, while your arrays and vectors are continuous in nature. Therefore, the insertion and deletion operations are costlier as compared to the insertion and deletion options in or operations in lists. So, when we talk about clear function, it is used to remove all the elements of the list container, and thus it is going to make the size, not the capacity, but the size as 0. So, it will delete the all the elements, all the occurrences of all the elements, and if we look into the syntax, you can have it on the screen, which says list name dot clear. And as far as parameters are concerned, no parameters are being passed, because we are not passing any range or any value. The whole of the list along with this clear function is being called, that whole list will be cleared, and all the elements of the list are being kind of destroyed. So, that is going to be the result. So, here we have just written into how to use this function. So, we have a list which is having 1, 2, 3, 4, 5. So, initialization of list is being done like this, and after calling this list dot clear, output is going to be an empty list, and if on empty list we are going to call this list dot clear, again the list is going to be an kind of empty list. So, this will clear out whatever is available, and if nothing is available, that is fine, then also it will kind of return an empty list. So, here we have seen the remove function, but before going into the remove, we have seen the erase function accepting range, and then after that we have also seen the clear function, and clear function is going to kind of give an error when there is a parameter which is when there is a parameter passed on to it, because as per the proper syntax it is not going to accept any parameter. So, this will be list dot clear function. Whatever the name of the list or with whichever object of the list we have called this clear, that particular object or that particular list is going to be cleared. So, there is no need of we can say parameters. So, this was actually the function clear, and in order to see it in a program, let us see this with the help of a quick code snippet, in which within the main function we have declared a my list of 5 members 1 2 3 4 5. So with this constructor we have passed on the values for the initialization. This is also one way of one way among various ways of initialization of the list container along with its declaration. So list within the angle bracket the type because we are using template. So this is integer, my list is going to be the new list with the elements 1 2 3 4 5, and if we say my list dot clear, all the elements will be removed or all the elements will be kind of deleted and the list will become empty. And if you are going to print the list before and after this, after using this clear, so before it was 1 2 3 4 5, and after if you are going to print this list by using for auto it is equals to my list dot begin till it not equals to my list dot end plus plus it, then this is going to give you a empty list after this remove function. Now time complexity if we look into is order n because all the elements are to be deleted. Auxiliary space is actually not a requirement. So order 1 is the requirement of auxiliary space, while time complexity is equals to the number of elements which are available in the list because all or have to be kind of cleared out. So we have seen the function remove, we have seen the function clear, and we have also seen one function, one version of the function which was erase, and that version was starting range is also given, so is the ending range. So from starting to the element prior having the position prior to the end element will be erased. So till this point we have seen these functions. Now in order to kind of proceed further, we are going to use two more functions which are kind of a little bit different from what we have considered till this point. These functions are r begin and r end. So r, as the name indicates, is nothing but r indicates here is the reverse. So when we talk about the r begin function of the list, that is an inbuilt function in C++ STL standard template library, and this is going to return a reverse iterator which points to the last element of the list. So begin is going to give you an iterator which is kind of in reverse iterator pointing towards the last element of the list. How are we going to use this r begin is just list name dot r begin. So that means this r begin is a function of this kind of list class whose object we have created in the name of list underscore name. So list underscore name dot r begin, we are going to kind of use this. So parameter, it is not going to take any parameter because the list name is included along prior to the dot operator. As far as return value is considered, it returns a reverse iterator which points to the last element of the list. So this was actually begin, and we can see this functionality of this r begin with the help of the program which is given as integer main. So we have started with a list, or we have kind of initialized a list named as lis, which is of type which is having integer data type, and it is having list as the container, and what is kind of contained in the list are basically 5 elements 10 20 30 40 50. And now using this r begin we can print this list in the reverse order. So for this we have a for loop which is given on the screen, that is for auto it is the iterator which is going to be returned by r dot begin. So lis dot r begin till it not equals to lis dot r end plus plus it, and then asterisk of it is to be printed. Now please notice two points which are very important here. Here we have used two functions. One is lis.rbegin, another one is lis.rend. I'll tell you what is the meaning of rend in a short while. And please notice that here, instead of the postscript post operator, we have used the prior version of the operator plus plus. So, instead of it plus plus, this is going to be plus plus it, and asterisk it is something which is being kind of printed. And when we talk about the output, so output is nothing but the list in the reverse order, and the the kind of normal order of the list was the 10, 20, 30, 40, 50, and the reverse order which is being printed is 40, 50, 30, 20, 10. And here it is going to kind of starting from the beginning, but as it is not the begin, it is r begin, it will start from 50 and it will end till 10. So, starting from r begin 50 till r end, which is 10, we have kind of printed the list in reverse order. So, by this example, I am sure that you all kind of clear of the list r end, which I am going to cover just now. But before going into r and functionality, the list in the reverse order is being printed as 50, 40, 30, 20, 10. Time complexity here is order n, auxiliary space is not much of a requirement, so order 1, but the time complexity of the operation is the linear time complexity. Now, with this there comes a function which is rend, again an inbuilt function in C++ STL that returns a reverse iterator which points to the position before the beginning of the list. The syntax is the list underscore name dot rend. Parameter, just like r begin, this is not going to accept any parameter. The list name is being passed before dot operator, and the return value is, it is also going to return a reverse iterator which is pointing towards the position before the beginning of the list, while in r begin the reverse iterator was pointing towards the position which after the end of the list. So, this r begin and r end, we can say they are kind of complementary to each other. So, here also we have as the example code of r end, we have given the same example, that is a list is being kind of made 10, 20, 30, 40, 50, and in order to print it in reverse order, we will start from r begin, which is the reverse begin, which is the kind of end element. We will go till r end, which is the reverse end, that means that is the kind of first position, and by using plus plus it, we will increment the iterator and we will print the value of asterisk it, which is the element available at this itr it. Similarly, of this kind of r begin, the time complexity of r end is order n, and the auxiliary space requirement is order 1. Now, one more function which is of kind of an important use is max underscore size, which is also a built-in function of a standard template library of C++, and this function will return the maximum number of element a list container can hold. Now, this is going to be actually a huge number when you are going to kind of look into. So, the syntax is list underscore name dot max underscore size, no parameters obviously. So, this function does not accept any parameter. As far as return value is concerned, this function returns the maximum number of elements a list container, that particular list container which is qualifying this max size, that list container can hold. So, in order to see this function, let us create a main method in which we have created a demo list, and without any initialization we just need to check the maximum size of the list, and that can be done by printing demolist dot max underscore size, and we have just printed that demolist dot max underscore size, and then there is a return 0. Now, what could be the output of this max size? So, output here you can see it is actually kind of a, we can say, a huge number, something of 3 7 6 8 6 1 4 3 3, and a very big number. Time complexity is order 1, because this is not going to take anything which is proportional or anything which is dependent to the number of elements present, and also we have not initialized any we have not inserted any numbers inside the list. Auxiliary space taken is order 1. So, till this point in this lecture, what all functions we have covered. We started with some basic operations of the list, and then we have seen the erase function with the two parameters, starting range till starting to ending, that is within a range. Then we have seen the remove function. We have also seen the difference between the remove and the erase. One is on the basis of value, another one is on the basis of position. Then we have seen the function clear, that is to delete all the elements of the list. Then after that we have started with the reverse iterator positioning with the help of r end and r begin, and finally we looked into the function max underscore size, which will return the max size of any list. So, here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed one. In this series, a lot more topic are yet to be covered. I will see you with a new topic in the next lecture. Till then, take care. Goodbye.